Welcome back. Let's do some factoring by grouping. So first I ask myself, is there a GCF to take out? But there's not. So I'm going to form the polynomial into two groups and ask myself, what GCF can I take out of each group? I can take an a out of the first group. That'll leave a b minus 6. I can take a 2 out of the second group. That'll also leave a b minus 6. Now I have a common factor, namely the b minus 6 in the parentheses. So I pull that out, factor it out, undistribute it from a plus 2. Next, we had a squared plus 2a squared, and I apologize, this was supposed to be an a cubed. So you know what, I'm going to stop talking for a minute and, well, you know what, I'll get that changed in the notes. So hopefully you guys should have a cubed in your notes. So I'll just go through it, assuming that you knew that that was an a cubed. Okay, so I make two groups. And notice the two groups are being added to each other. I don't need to put a plus in because there's one supplied for me, but I'm just pointing out it's not that there's nothing between the parentheses, because it's not a multiplication, it's an addition. Okay, what can I take out of the first two terms? An a squared, that'll leave me a plus 2. What can I take out of the second group? A 5, that'll leave me an a plus 2. Because I have the same stuff in both parentheses, I can factor it out of the a squared plus 5. And at that point I'm done. A squared plus 5 does not factor further, so you cannot go any further than this. Quick reminder, you can always check your work. Now I don't blame you if you might not have done in this case because you knew I was going to come back and give you the answer, but on a test that wouldn't be the case, right? No one's going to give you an answer before you leave the test. So it's a good habit to get into. A times a squared is a cubed. A times 5 is 5a. And I have a 2a squared, and I have a 10. Is that the same as what I started out with? Yeah, sure. The 5a and the 2a squared are written in a different order, but addition's commutative, so it's the same thing. So our answer checks. Okay, going on to the next one. This time there is a GCF I can take out. I can take out a 2. So let's do that. That'll leave me x squared y squared plus 3y squared minus 10x squared minus 30. Oops, I forgot what I was doing. 2 times x squared y squared plus 3y squared minus 5x squared minus 15. That should be it. Right. Okay. And now I'm going to separate my two terms into two groups. But remember, I need a plus sign between my two groups because they're not multiplying each other. And if I don't put the plus sign, I'm saying they're multiplying, and they're not. I keep my big parentheses, but inside the little pink parentheses, I ask myself, what can I take out? And I can take a y squared out of the first set of parentheses, leaving an x squared plus 3. Then I have this plus sign. What can I take out of the second two? I can take out a 5, but let's make it a minus 5. And actually, since I have a minus there, I don't really need that plus sign, because plus minus is the same thing as minus. I'm left with an x squared plus 3. And good news, I've got the same thing in both sets of parentheses, so I can take it out of the y squared minus 5 that it had been distributed into. So your final answer would be 2 times x squared plus 3 times y squared minus 5. And note that in this step and this step, those big parentheses are mandatory. Down here, though, we don't need them, so we drop them off so that we don't have an unnecessarily complicated expression. If you don't get why that is, you might go back and watch the previous video, the example where we had to do that. Okay, and the last one on here, xy minus 5x minus 10 plus 2y. I asked myself, is there a GCF for all of those? And no, there's not. So I can go right to grouping. Now, I need to get this minus sign inside those parentheses, which means I need a plus between them. There's not much room there, so I'll just stick it there. What can I take out of the first set of parentheses? An x, so that'll leave me y minus 5, and then plus, what can I take out of the second set of parentheses? 2, and maybe we want a negative 2, maybe we don't. I'm going to take out a 2 for now. That'll leave me a negative 5 plus y. Now, it doesn't look like I've got the same thing in the two sets of parentheses, but notice I actually do, right? Because negative 5 plus y is the same thing as y plus negative 5, because addition is commutative. You can swap the terms. And then once I've got y plus negative 5, well, plus negative is the same thing as just minus. So yeah, I have the same thing in both sets of parentheses. So I can undistribute it or factor it out from the x plus 2 that it had been distributed into. So that wraps up what we've got for factoring GCFs and factoring by grouping for now. So I'll stop there, and we'll see you with something different next time.